Okay, so on part B, it says, at what time does the particle change directions? And then justify your answer. Okay, well, here's the thing. The only way the particle can change directions is if it stops. So it could have been going to the left or the right, either way. So in other words, I need to know when the derivative is equal to 0. That will tell me when the particle potentially could change directions. All right, so here we go, back to x prime. All right, we're just going to set it equal to 0. And so that was 3t squared minus 9t minus 12. And we want to know when that's equal to 0. Well, you can divide all of that by 3. All right, and that would give me, this will happen the same time, t squared minus 3t minus 4 is equal to 0. All right, and that factors all day long, and that factors as t minus 4 and t plus 1. Now, that gives us two potential moments when the particle changes directions. And so the first would be when t is 4. Okay, and the other is when t is equal to -1, but that can't be because this thing starts when t is 0. So t cannot equal, I'm just going to go ahead and write not equal -1. All right, so 4 is the possibility. Now, so here's what you do. All right, we want to check to see, we know at 4 the velocity is 0, but was before that, was it negative or positive? And after it, was it the opposite? Because if so, it changed directions. So what we can do is we can just try a couple of points here. Let's try x prime at 3. So the velocity at 3. And let's try x prime at 5. And just see what's going on. All right, now, so x prime at 3, here's a nice place to find out. If I substitute right there, 3 minus 4 is -1. And 3 plus 1 is 4, which is going to be a positive. So really, I could just set a negative times a positive. But either way, it's negative. Okay, and then at 5, 5's a good one because if I substitute 5 in, I get positive on both of them, don't I? So that would be 5, 5 minus 4, 1. And then 5 plus 1, 6. And that's positive. All right, so what I did was I just checked a couple of points on either side of my critical number, my t equals 4, to see what was happening. And I discovered that indeed it did change directions at that point. Okay, so it says justify your answer. And I guess we could say, let's move that out of the way. We could just say, text box right here. Since the velocity changed from negative to positive, at t equals 4, the particle changed direction. There you go. That'll work. All right. Then, all right. At t equals 1 is the velocity of the particle increasing or decreasing? Well, that's asking you about acceleration. Is the velocity going up or going down? All right. Well, that will be the second derivative. Okay. So acceleration is the second derivative. All right. And so, and I will say that up here, I could have said velocity of the particle, that would have been fine. But now I could say acceleration of the particle at time equals t would be the second derivative of position, also known as the derivative of the velocity, since I called that velocity up here. Okay, so either of those are fine. They're all the same thing. And so let's take the derivative. And the best place to do that is either spot. But I'm definitely going to do it right here with that constant multiple there. So I'll have I don't want to divide. I don't want to have divided by 3. So not any spot. Right there is the best place to do it. So that's going to be 6t minus 9. Okay. And then it's asking acceleration at 1. So I just substitute 1 in. That'll be 6 minus 3. 6 minus 9, sorry, which is negative 3. Okay. So, all right. So then I would say, there you go. There you go. A little text box right here. At t equals 1, the velocity of the particle is decreasing due to the acceleration being negative. You can say that a bunch of different ways. You could say because the derivative of the velocity is negative. You could say the second derivative of the position is negative. All those things are saying the same thing. But when I hear of the particle, whether it's increasing or decreasing, I immediately think of acceleration. All right. So B and C, we'll pause right there.